Hello everyone, we are a team of computer engineering students with an AI concentration from Abu Dhabi University. Our project, which is the low-cost machine learning for intelligent data harvesting, is developed by Muhammad Abdullah, Muhammad Faris, and Hadi Al-Banna under the supervision of Dr. Jawad, Dr. Taimur, and Professor Muhammad Ghazal. Here's a quick overview of our presentation, where we begin with the problem and motivation, followed by the proposed system, and then the results, and finally the conclusion. The UAE is one of the world's leading data producers with over 40 million palm trees. However, current monitoring and harvesting methods remain largely manual, making them inefficient and labor-intensive. These practices contribute to environmental challenges where the lack of real-time monitoring limits effective decision-making. This highlights the need for intelligent systems that can automate monitoring and support the sustainable harvesting. To address these challenges, our work is motivated by three main goals, starting with improving the efficiency using robotics, AI, and IoT for better monitoring and management. Second, reducing environmental impact by optimizing harvesting decisions using real-time data. And finally, introducing a lightweight and innovative machine learning solution that supports sustainable farming and aligns with the global sustainability goals. Next, Mohammed Faris is going to take you through our proposed system.
Welcome everyone. I will present our end-to-end automated system for agriculture monitoring, specifically designed for date palm farms. Our system is mounted on an autonomous robot that navigates through the farm using an AgriVision camera. It uses image segmentation and lane tracking to move safely and accurately along the paths. When the robot is in the position, as you can see here, the core of our project activates. We use depth camera and ULOV8 algorithm to detect and locate the date punches on the trees. Then we will capture images using our Raspberry Pi, and the Raspberry Pi will process them through lightweight machine learning models. These models classify two things: the exact type of the date and its maturity stage. Finally, this processed data is transferred wirelessly to a Firebase database for real-time monitoring by the farm operators. And now we will move to our lightweight classification machine learning model. Now let's look closer at the first step of our AI pipeline, detecting the punches. For this, we implemented the YOLO V8 architecture because it is currently the state-of-art model for real-time object detection. Since our system operates outdoor in complex lighting and overlapping punches, we need something highly robust. As you can see here from our training results, the model performed as we expect. We achieved a mean average precision of 96.8% and a precision of 96.9% and a recall of nearly 92%. This means our system is highly reliable at detecting the punches without producing false positives. So after the camera detects the date punches, we need to figure out exactly what we are looking at. To teach the AI how to do this, we gathered photos of dates and stored them into groups. So after splitting our dataset to training, validation, and testing datasets, we used image augmentation for our training datasets, which means we flipped the images or changed the lighting so the AI learns to recognize dates outside in the real-world environment, no matter what the camera sees. To make the AI more smarter, we didn't build its brain from scratch. Instead, we used a transfer learning model, which means we took an AI that already knows how to recognize basic shapes and pictures, and we just taught it at the final step how to recognize our specific dates. At the end, after our classification system, we will get our date type and maturity stage. And now we will proceed with my colleague Hadi.
Now, following up with what my colleague Farid has said about the dataset, here are the characteristics of the dataset. On the far left, you could see the different types of dates that we could expect in the farms. Khalas, Barhi, Minefi, Boot Safe, and the last one, Sulaj. As you can see here, here are the different maturity stage that a date can go through. Here, for example, we have Barhi, where we have immature, Khalal, Rotab, and Tamar. Coming to the training, validation, and testing division. On the left table, you could see the date type division, where we divided the images for training, validation, and testing. And now on the right, we have the table of the maturity stage classification division, coming to a very crucial point in our project, which are the hyperparameters and the CNN models that are going to be. For the hyperparameters, we chose the optimizer, mini batch size, and the number of epochs to make our model more reliable. Second, we evaluated multiple CNN models to get the best results from each model.
These are the results of the MobileNet version 2 and the DenseNet model for the date type classification. As you can see in these graphs, both models achieved high accuracy with stable training and validation performance, where the confusion matrices also show strong results with most prediction concentrated along the diagonal, which indicates the correct classifications. Overall, while both models performed well, DenseNet slightly outperforms the MobileNet version 2 model across the evaluation matrices. Here we compare the NASNet and the mobile models, where the NASNet shows strong performance while the mobile model has significantly lower accuracy. As an overall, NASNet performs better for this task as shown in the confusion matrices. Among all the tested models, EfficientNet B0 stands out as the best performer in the date type classification, achieving the highest accuracy comparing to the other models.
And to make sure we picked the absolute best AI for our robot, we did not just test one model. We tried out several small and fast models. As you can see here, the test results for two of them, MobileNet version 2 and DenseNet. To check how smart they really were, we looked at a few different charts. We focused the most on F1 score. This score is important because it makes sure that the AI is actually good at recognizing every stage of the date. As you can see here, both of these models did a really good job, and we continued with our testing with EfficientNet and MobileVet. Notice that EfficientNet results on the left. The confusion matrix is incredibly clean, showing very few misclassifications across all maturity stages, completely outperforming the MobileVet model on the right. As shown here, the F1 score is 0.67. We tested 9 different AI models in the exact same way based on Adam Optimizer and choosing 50 epochs to make it a fair comparison. So finally, we chose EfficientNet B0, which scored an amazing 98% accuracy and 0.97 F1 score.
Now, coming to the comparison with the legacy studies, we chose the legacy studies that had the same exact data set for fair comparison. The EfficientNet B0 has one of the highest scores, the date type classification, which shows that our model shows competitiveness can match the already existing method and even outperform it. This table discusses the comparison with the legacy studies, but this time it's about the maturity stage. As you can see here, also our model, the EfficientNet B0, highlighted in yellow, also outperformed almost every existing model there is. And now we are going to check a live demonstration of our system. Here the robot is navigating around the lanes, and at this moment it finds a barcode, and this barcode is connected to a tree so that the robot locate this tree. And after the robot takes images of the bunches, it will go to a database, Firebase. Now coming to the GUI, or the graphical user interface, that the farmer will see on his phone or laptop. After uploading the image, first we'll classify which type of date it is. As you can see here, the result is Barhi, 100% confidence. And then here we will receive the report of it. We will get the date type, the maturity stage, and the decision of harvesting. And also the image of the tree, so that the farmer knows which tree the robot is looking at currently. And then we can print the summary report of the overall results that we got from the robot. And also on the email connected to the robot, you can get the daily notification. To sum up everything that has been stated so far, comparing multiple CNN models for classifying both date type and their maturity state. We analyzed 5 different date varieties, as we saw before, and assessed the model performance using both validation and the test accuracy. Our results shows that the EfficientNet B0 outperformed all other existing models and methods that has been shown in the legacy studies, achieving up to almost a test accuracy of 98% for both the date type and the maturity stage classification. In addition, it is considered a very lightweight model compared to the AlexNet, VGG16, 19, and the NASNet. Finally, for our future work, we are planning to even optimize more the hyperparameters and get much better results and use multiple vision transformers for better accuracy.